Hi team, so I just want to make this video to show you the best way to go about playing back multiple sound files in processing and how to basically change the pitch of the playback of those sound files by basically changing back the playback rate. Now, if you check out the code that I shared with you, I'll kind of go through what's going on here. So this is using the sound library for processing. If you don't have it, you can go through the same process of going to sketch, import library, add library, and then you should be able to search for sound. And then it'll be this library down here, which is the one that's by the Processing Foundation. So we're using that one instead of Minim, or one of the other options as far as sound libraries for processing, because there are multiple options. Now, the next thing we want to do is we want to create a list of sound files. So this is the object, the sound file object. These two brackets denote that we're creating a list, so basically multiple instances of the sound file that are stored in the same object. We're calling it sound files. And then right here, this is sort of the initialization. So we're saying this is going to be a new sound file list that contains 3 different files. So it may be kind of confusing, but basically you want to change this 3 to however many files you're going to be using for the program. Now, just for the purposes of this example, we need to have this integer for active person, which will determine which one of the circles we can move with the mouse in order to experiment with this functionality. Likewise, we have this variable total people, which is just used as a shorthand later on for some loops to make things easier to read, which this just corresponds with the same number up here, which is the number of sound files we have, or the number of people that the system can be aware of. Last thing we have is a p-vector for person position. So this will have p-vectors are basically a list that stores coordinates. So we're using it to store an x position and a y position for all the people within the space. P-vectors also have a z position, which we aren't going to use, and I wouldn't use for your example either. So this is kind of the same thing as when we're creating these sound file objects above, where we're creating a new list of these p-vector objects, where it has a total number of units according to this total people variable. So this is just a list that's keeping track of the location of the people in the system, which are represented in this example by these ellipses, which you'll see later on. Then we have the setup loop, right? We're creating a canvas, which is square. We're giving it a background color, which is white. Then we are loading our sound files into the sound file array. So we need one of these lines for each different sound file we're loading in. So we say which index we want it to be in. We're saying it's a new sound file. This just refers to this program. Don't worry about it. It has to be there. And then the name of the sound file itself. And then in order to add the files, you can just simply go into Finder and then drag it. And then it will say down here, one file added to the sketch. And then you can just say the name of the file, and then processing will be aware of the file hunky-dory. There's a little bit of information here if you want to print out the sample rate, the number of samples, or duration of the clip. These are commented out, but if you want to get nitty-gritty, you can do some sort of logic based off of that, which is definitely a possibility. The next thing that we do is for each one of the sound files, we do want to get processing to start to make sure it's in loop mode. Otherwise, once the file is finished being played, it would have to be reset to the beginning, or else you won't be able to play it again. So this fancy format for the for loop is just basically saying that we want to grab the sound file object from the sound file array, and we want just the object. We don't want to have like an integer I that we have to use to get the index of it, etc., etc. Instead, this is kind of shorthand where we can just get a custom named sound file object from this list of sound files. And then we call the loop function on the sound file object. All right. Likewise, for the we're setting a default location for the ellipses. So we're just taking width divided by, let's just divide it by I. Oh, we can't divide by 0 though. So let's divide it by, alright, well I guess we'll just still keep it divided by 2. So this is going to stack all of them. We'll do plus I times 20. And this will sort of stagger them out a little bit. And then height plus 2 plus I times 20. And then we're just putting these brackets in here to be ultra sure. Well, actually, we don't need them. All right, cool. So that's just giving a default location for ellipses. I just changed the code slightly so that they aren't stacked on top of each other. And we can see that there's 3 at the beginning. Then we have the draw. So this first section up here just kind of deals with setting things up and drawing the text that tells you what to do. So we set the background. So actually we don't need to set the background up here in the setup. We can take that away. So we set the background here. Then we're setting a fill color. And then we are displaying the text at that fill color. Then we're giving ourselves a stroke color, which is black, and then we're giving ourselves a slightly different fill color, and then we're going through, we're grabbing the position for each one of our people's positions, which is using that same sort of shorthand for the for loop. So instead of doing this down here with the I and then having to use the index I, we're grabbing this p vector directly. And then with p vectors, we can say .x or .y to get the x position or y position. That's what's nice about vectors. They're easy to understand. And then we're setting a size for ellipse. So we're actually drawing the ellipses, which will represent people. So when you adopt this code for your project, you want to basically replace these, you want your blob detection to set these p vectors into the appropriate x and y positions, or you want to just take the x and y position from your blobs basically and then use that later on in the sketch. Cool. Just for the purpose of this example, we're using the mouse pressed variable, which will be true whenever your mouse is pressed. We're using the mouse to basically use mouse to control the location of the circles, which is what we're doing. So when the mouse is pressed, we're taking the mouse x coordinate and we're setting that as the x coordinate for the person that is relative to whatever the active person variable is set to. Likewise, we're doing the same thing for the y position. Then for feedback, just to sort of better understand hopefully what's going on with this, we're printing out this list of person positions. So we have the first person, second person, and third person, their relative position. Like I said, the p vectors will store x, y, and z location, but we're only going to use x and y location. So that's why the z, this third number right here, is always 0. Don't worry about it. Alright, and then here's the actual meat. So this is actually what you probably care about most. We have a for loop where we're going through each one of the sound files. And we're using the length of the sound files to increment this variable I, which starts at 0. And then we keep on climbing up, right? Just like a normal for loop. And then to make things a little bit easier to read, a little bit easier to read later on, we're grabbing the x position for each one of our people, or the circles in this example. And then we're grabbing the y position and we're storing into these floats x and y. Alright, and then we're grabbing the sound file that corresponds with that person. So remember, we're using index I for each one of these. So this will be 0 first time through, 1 second time through, meaning that we will grab the first person and the first sound file, or the second person, second sound file, so on and so forth. Then we're calling .rate on the sound file. And this will change the playback speed of the sound, and therefore also changing the pitch of it. So the sounds that I have loaded into this example are these loops of a single instrument that I pitched up and down in Audacity. By changing the rate of these loops, we're able to change the pitch, and we're able to tune or detune these instruments. And then the last thing that we pass in is what we want the rate to be changed to. So we're taking x, which remembers the x position of the person, and then we're remapping that. So we're saying the lowest that we expect for x is 0, which makes sense because that's the lowest x coordinate for a pixel that we can have. And the highest that we expect is width, which makes sense because that is the total width of the display and is the highest pixel count that we can actually get the x coordinate of the mouse to go to. Then the next two is what we want to remap the low to, and then what we want to remap the high to. And this is going to be the playback rate. So if we have 2, for instance, this pass into the rate, the sample will play back twice as fast and the pitch will be 1 octave higher. If we pass 0.5 in, it will play back at half speed and it will be 1 octave lower. So I'm giving a minimum of basically a 2 octave shift downwards and a 2 octave shift upwards by passing 0.25 and 4.0. A little bit easier to understand, we're then using the y coordinate of the person to be mapped to the amplitude of the file. And then we have a minimum of 0.2 and a maximum of 1.0. And likewise, we're using the map parameter just like we did with rate, but we're taking in y, and then we expect it to go from 0 to height instead of 0 to width, as we did with the x. Alright, cool. The very last thing that we do, which is also something that will be important for what you guys want to do, is that we are panning the sound files then. And we're using the y position to pan it. We're calling soundfiles.pan, and this is pretty much the same as soundfiles.amp, except for with panning, -1 will mean that the file will come completely out of the left channel, and 1 will mean the file will go completely out of the right channel. If you have 0, it means it will go equally out of both channels. Now, one thing to note is this is within this little if statement here that says if soundfiles.channels equals 1. So that is basically making sure that the sound file that's loaded in is a mono file. If the file is a stereo file, this will not work. Alright, cool. So hopefully this was helpful. Basically, you need to integrate this program here with the other programs I shared with you earlier today. And you need to add this audio playback functionality to your system that is reading the Connect. You would probably want to make use of pan and then rate. You would use rate to tune or detune the samples that you're using. And you'd probably want to use a much smaller sort of window, something closer to 1.01 to 99 or something like that. You want it to be much more minimal. And then you probably want to use the pan as well. And it doesn't have to be super crazy or complex. Just try to get these pieces working together, and then you'll be all caught up. You'll be in a good spot. And actually, so let me run this real quickly just so I can show you what's going on. So here we go. So remember I had them offset, and you can hear that horrible sound is detuned. But then if I place these circles on top of each other, they're not perfectly in tune, but they're getting a lot closer. Oh, you hear that? It's real nice and out of tune. So each of those 3 notes make a major chord. But let me show you what happens if we instead use the same file for all 3. So this would be cool. And then let's change the tuning so it's less noticeable. So we'll do only 1% change. So there you have them all out of tune, fanned out. And back in tune again. Alright, and we'll do one more, but this time we'll have a 10% field. Alright, so we have them in tune. We're detuning the first. We're detuning the second. And then we'll bring them back together. Alright, hopefully this is helpful. Good luck.